My name is Matt. I'm here to guide you in answering exam type questions and also showing you some techniques in answering any exam questions. I'll be providing you some additional tools that you need to answer each questions as we go along in answering past year papers. Let's look at some examples and some past year papers. We'll start off with 2024 paper, and question number 1 says find the value of the following: I squared. Okay, let's look at what is I squared. Now, before we answer I squared, let's look at some information or some ideas around this concept. Now, for complex numbers, in your lower level mathematics, we say that square root of 4 is equal to 2. But when we come across square root of -4, we press that in the calculator. Let's press this in the calculator and just see what is the square root of -4. Square root of -4. If we press that in the calculator, it gives us a 0 or an undefined answer. Now, in many cases, when we come across a square root number, mostly in quadratic formula, when we are solving quadratic formula and when we press a negative number inside the calculator, it gives us a undefined answer or a maths error. So that's where we're stuck. We cannot proceed further. So mathematicians, they said, okay, if it's stuck, then what is the way forward? Now, they came up with this background information where people say, okay, we know that this is a square root value, and then we need to apply the square root law just to find a light out of this value. So they applied the laws of square root. So the laws of square root says that square root of A times square root of B is equal to square root of AB. Okay, what else? They used this law in answering this question. I'll just write it here because the space is more longer here. Square root of A times square root of B is equal to square root of AB. They are multiplied, so that's that. And the second law says square root of A divided by square root of B is equal to square root of A divided by B. These are the fundamental laws of surds or indices, in square root. So we'll apply this law here. So they say that if we come across square root of -4, then people will be stuck in solving problems where the square root is. So they came up with a law says, if this is square root of -4, I can break this down as square root of A times square root of B, meaning I can say this is -1 times square root of 4. Because -1 times 4 is -4. And since these are multiplied, I can break it down using this formula. Now let's go. So square root of -4 is equals to, what is square root of -1? They know that square root of 4 is 2. Yeah, square root of 4 is 2. But then they said, okay, the problem that lies here is this square root of -1. So they said, okay, since the problem here is the square root of -1, And okay, they said, okay, how about we say that square root of 1, we refer them to an alphabet. So they refer square root of negative 1 as I. So they're saying, okay, if that's the case, then whenever we see I, or whenever we see a value I inside the topic of complex numbers, this I refers to negative 1. So they came up with this value saying square root of negative 4 is equals to I, and I is negative 1, and they said that square root of 4 is 2. So 2 times I, apple times orange is apple orange, so apple times orange is apple orange, so 2I. So this is where I comes in. Okay, now using that information, we know, using that information, since I is square root of negative 1, I can also say, I'll just use this space because it's just along here. So if I is equals to square root of negative 1, then what is I squared? We know that anything that is squared, meaning A squared is the same as A times A. So if that's the case, then I squared is the same as I times I. And if I times I, but what is I? I is square root of negative 1. So square root of negative 1 times square root of negative 1. A times A gives you A squared. Square root of negative 1 times square root of negative 1 is square root of negative 1 whole thing squared. And we also know that squared and square root, they are opposite, they cancel out. So this is left with negative 1. So we say therefore I squared is equal to negative 1. So our value here is I squared is equals to negative 1. That is our answer for question number 1. These are the information around this value under complex number. Let's move on to the second question. Okay, the real part of Z. So let's look at question 2. The real part of Z. So let's look at Z is equals to 4 plus 9I. Okay, let's look at those questions. The real part. Okay, before we look at the real part and the imaginary part, I'll just explain you a little bit information regarding complex numbers and the values of real and imaginary. Now, just to keep things simple, I'll just give you an information around this concept. Just an information regarding that. Let's say if we have a value of okay, in your lower level we come across equations of y is equals to 3x plus 4. That's in your lower level. But when you come up to complex numbers, it's no longer y. We call that z. We call that z or omega or whatever it is. We call that z is equals to, let's say, 3 plus 4i. Now, this remains the same. So in this case, whenever we see a value 3, a whole number, we call this value our real value. And a value that is associated with I, we call that an imaginary value. Okay? So our real value has only a whole number. It can be decimal, it can be fraction, as long as a number without an I. So a number without an I, we call that a real number. a number that is written with I, we call that an imaginary number. Okay? Now, this whole function, or a function, or a complex number, or a complex equation in the form of I, or where I is, we call this equation complex equation 3 plus 4i. Where the I is, we call this complex equation a rectangular form. So this is called a rectangular form. We'll use this inside. Okay? Okay, so our real value is this value, our imaginary value is that value. We can use it here. What is our real value here? Help me here. Our real value is, yes, 4. This is our real value. And what is our imaginary value? Yes, the one that has an I. So this is our imaginary value. Okay, let's just stretch it. Let's stretch this information. Speaking of this, because we're already here, we'll use this inside. So I'll just break it down for you. This is a rectangular form. Now, similarly with x and y, we normally have a linear equation and then we sketch. And whenever we sketch, we first find the x-intercept and the y-intercept. Once we know the x and y-intercept, then we're able to sketch it on the graph on a linear plane. Yeah? Okay, similarly here, in a complex number, we also have the graphing. In a x and y plane, we have an x-axis and a y-axis. So x-axis and a y-axis on an xy plane. For a complex number, instead of x, we say a real value, and instead of y, we say this is our imaginary value where I is. So instead of our x-axis, we say real value, and instead of our y-axis, we say that that's our imaginary value. Okay, so let's try and sketch this function. So if we sketch this function, what is this function? This is our value of, this is our real value, and this is our imaginary value. Okay, since this is I is already there, so we just take out the value. Our real is 3, so I'll go on to my real axis. So 3 is above 0, so 1, 2, 3. And our y value is 4, so 1, 2, 3, 4. Where do they meet? They meet along that line. So this is our graph. This is what we call an Argan diagram. Argan diagram. So this is our Argan diagram. And that's how we sketch them. The second value, or the second questions they usually ask is, what is the modulus of z? So the modulus of z. Now the modulus, or the r of z. The r of z. Now, where is the modulus of the, or the r of z? This is our modulus of z, the hypotenuse. Okay, to find the hypotenuse, we notice that this is a right angle triangle. Yeah, a right angle triangle. So the distance from here to here is 3, and the distance from here to here is 4. Now, if this is our angle, then I say that, or I normally teach my students is, where the angle is, where the side where the angle is always our adjacent. So this is our adjacent, and this is our opposite. Okay, we'll use this inside. But I want to find my z modulus. Z modulus, since this is a right angle triangle, we'll use what we call Pythagoras theorem. Pythagoras theorem is c squared is equals to a squared plus b squared. Now, we'll only use Pythagoras theorem once our triangle is a right angle triangle. If it's not a right angle triangle, we won't be able to use the Pythagoras theorem. Pythagoras theorem will only be used if it's a right angle triangle. So let's go. C will always be a hypotenuse. A and B can be either our adjacent or our opposite. We want to find C, our Z modulus. So C is our Z modulus, so we want to find C. What is our A? Our A can be either adjacent or opposite, so I'll just take that as 3 squared plus B is 4 squared. So 3 squared is 9 plus 4 squared is 16, that is C squared. So 9 plus 16 is what? 9 plus 16? Yes, 25. So this is 25 into C squared. You want to find C. We'll take the square root. Opposite of squared is square root. They cancel out. C is equals to square root of 25 is 5. So this is 5. So we can say therefore 5 is our hypotenuse. So we can say that therefore Z modulus is 5. Or we can say this is our value of R. R is equals to 5. We'll use this inside. Yeah? Okay. Now that we know our R, let's just stretch it because we'll use this inside. Now that we know our R, can we find the angle? Yes. And how can we find the angle in a right angle triangle? How can you find the angle? Yes, using SOHCAHTOA. So we'll use SOHCAHTOA. SOHCAHTOA is only used SO, KA, and TOA. So, KA and TOA will only be used if you are finding an angle inside a right angle triangle. So S represents sine. So S theta is equals to opposite O over hypotenuse H. K represents cos. So this is cos theta is equals to A is adjacent over hypotenuse. And TOA represents tangent. Theta is equals to opposite over adjacent. You'll only use this depending on the value given. Okay? Depending on the what? Value given. Okay, let's go. Let's identify what is the angle. But what are the values given to us? Values that are given to us is our adjacent and our opposite. So adjacent and opposite are given. So adjacent and opposite. So which word does it form? A and O. A and O here. It forms the word TOA. So I'll use tangent theta is equals to opposite over adjacent. So what is my opposite? Our opposite is 4. So 4 divided by, what is our adjacent? Adjacent is 3. So we left with tangent theta. I want to find theta. Tangent, take it to the other side. What is that equal to? Yes, tangent inverse. So theta is equals to tangent inverse of 4 over 3. So tangent theta is, what is tangent inverse? Press your calculator. So let's press our calculator. Tangent inverse, so shift tangent, so tangent on top is tangent inverse. So tangent inverse of okay, before that I just need to program my calculator. This is not FX, it's a different calculator. So let's just program it fast kind. It's radian. So this is in radian, I want it in degrees, so this is F1 and exit. Okay, let's test sine of 90 should be 1. Yes, so the angle is in degrees. So let's convert this value. Let's convert this value. So tangent inverse of 4, just press it like the ones you see it, 4 divided by 3. So 4 divided by 3, close the bracket, equals. So that is 53.13 degrees. Now that is the angle. This is our Z modulus or R. Okay, let's stretch it again. From here, remember, I'm just telling you we'll use this inside. Since we're here, I just want to show you. Okay, since we have our Z modulus or our R, so we say therefore our R is 5 and our theta is 53.13 degrees. The next question they will ask you is convert this value rectangular into polar. So in polar form, the value for the polar form is this. The general formula for polar form is Z is equals to R cos theta plus R sine theta I. Or they can say, since R here, we factorize, put R out. Z is equals to R, because they are common, put R out. R into cos theta plus I sine theta. Since it's a long value, they can simplify this as R. Since this is cos and sine and I, they can say cis theta. So R cis theta is a short form of this. This is called a polar form. Okay, how can we convert this value into polar form? So now that we know our R, now that we know our theta, we can substitute and convert this rectangular form into polar form using this value. So this is Z is equals to, what is our R? Our R in this case is 5. C is, what is our theta? Our theta in this case is 53.13 degrees. This is our polar form. Alright, let's try and check if this is correct. So let's try and come from here to here using the calculator. So you can either find this in the calculator, it's easier way to find this, but this is what the calculator is doing. So let's convert this rectangular into polar. And how can we do that? Rectangular. So this is 3. I'm not going to use this calculator, but I'm just going to use this calculator. So I'll just try and zoom in so you can see. There's a value here. We want to convert this value Z is equals to 3 plus 4I. Okay, to come to this value. So let's press this in the calculator. Okay, let's press this in the calculator. What is, or how can we find this value in the calculator? So we just press this in the calculator. Polar, there's a value here called pole. So pole, and punch in whatever value you have here. Here is 3, so we say 3, comma, there's a comma here, comma, and whatever value, if it's positive, you put in positive, if it's negative, you put in negative. Whatever value here, you put it here. So since it's positive 4, so we'll just put positive 4. Similarly, in your real value, if it's negative, you can put it negative. Whatever value it is, if it's decimal, put in whatever value you put it, it'll give you the same answer. So in our case, it's 3 plus 4, so 3 comes first, rectangular comes first, and then imaginary comes second, and then close the bracket, equals 5. That value 5 is your real or your Z modulus. So the calculator is doing all this and gives you 5. 5 is your R, so we can say R is 5. And then how can you find the angle? How can you find the angle? How can you find this angle? Okay, to find that angle, we press this. To find the angle, this angle, 53.13, how can you find the angle? You press recall, there's a recall here, recall, tangent value, tangent button. Recall tangent, it gives you 53.13. So that is our angle. So you can press this in your calculator, so 53.13. So we convert, so we have converted 3 plus 4i, 3 plus 4i, 3 plus 4i into, so 3 plus 4i is 5, so 5 C's 53.13. I hope that that's cleared. I hope that you have understood that part. So in this case, I'll repeat that again. If you want to convert 3 and 4 into polar, so you press pol, and then you press 3, comma 4, close bracket, equals 5. That is your Z modulus. So if you want to convert Z is equals to 3 plus 4i into polar, so we say that you press this in the calculator, your R is 5, and C's, because R C's theta, C's, you want to press your, want to find your theta, press recall and tangent. So this is 53. So this is 53.13. So this is 53.13 degrees. So this is your answer in polar form. Okay, let's try and convert. If polar form is given, and you want to convert it back to rectangular form. Rectangular form. How can we do that? Going back to here, same process. You'll notice that the button pole above it is called rec. So we press, its color yellow, so you press shift and pole, and then you press whatever first value comes in. Our first value is 5, so 5, comma, same thing, comma, and whatever value here, it's 53.13, so 53.13, close the bracket, equals, our answer is 3 point, there's a point there, there's a point here, so 3.00 is same as 3, and then you want to find your angle, so recall tangent, it's 3.999, that is 4, and see if it's positive. Yes, it's positive, so positive 4, and this is your imaginary Z, and it comes back to this value. So that's how we convert. Polar or rectangular to polar, and polar back to rectangular. That's the conversation regarding polar and rectangular. We'll use this inside. Okay, those are the additional information that I want you to understand before we move on. Remember, we'll use this inside. Okay, let's look at the second question. The real value here is 4 and the imaginary value in part C. What is the imaginary value in part C? Yes, negative 3i. So the imaginary value is negative 3. Let's answer D. Let's answer D. So D is saying, let's answer D. D is 2 plus 3i plus 5 minus 3i. Okay, this is 2. This is 2 complex numbers. Sorry. This is 2 complex numbers. So what we do is we try and solve them using the concept that we have seen. Okay, let's try and solve them so that we try and adjust our camera. Okay, let's try and solve them. So this is how we will look at it. Let's say this is omega is equals to 2 plus 3i, and z is equals to 5 minus 3i. So the question is saying, since they added, so this is omega plus z, and omega plus z is, omega is 2 plus 3i, and plus is z is 5 minus 3i. Okay, how can we solve them? Remember, whenever you adding complex number, you can only add real with real and imaginary with imaginary. Let's look at this example. So in this case, we will add them like this. 2 plus 3i, since they're added, plus 5 minus 3i. So whenever we add them, so we add the real with real. This is our real value and this is our imaginary. We only add real with real and imaginary with imaginary. So let's go. 2 plus 5 is what? 7. Yes. Now positive times negative. Let's look at the law. Positive times positive is positive. Negative times a negative gives us a positive, but the difference is when I add the two. Positive times a negative will give me a negative. We'll apply it here. Positive times a negative, positive times a negative will give me a negative. So our value here would be negative. So 3i minus 3i. So 3 apple minus 3 apple is 0 apple. So our answer here is omega plus z is equals to 0. So we can say, therefore, 2 plus 3i plus 5 minus 3i is equals to 0. Oh, is equals to 7, sorry. Because 0 is or plus 0i. That is your answer. I give you 2 minutes just to do this as an exercise. Suppose we have omega is equals to, just use the same concept and minus z. Omega minus z. I give you 2 minutes, subtract them. Remember, we can only add and subtract real values. We can only add and subtract the imaginary values. Try to solve omega minus z. 2 minutes, and your 2 minutes starts now. Okay, let's try and solve this together. So your answer would, what is our omega? Our omega is 2 minus 3i, and minus comes down. What is our z? Our z is 5 minus 3i. Okay, let's solve. What is 2 minus 5? So please, if you're not sure, you are allowed to use calculator. So we'll just use the calculator for now. 2 minus 5. So 2 minus 5 is minus 3. So we have minus 3. Now negative and negative. Negative times a negative. Negative times a negative will give me a positive. So this should be a positive. So negative, hey, omega. Omega is, sorry, omega is plus. So this is plus. So 3i plus 3i, because omega is 2 plus 3i. So 2 plus 3i minus, your z is 5 minus 3i. So 5 minus 3i. So let's solve them. 3i plus 3i. So 3i plus 3i. 3 apple plus 3 apple is positive 6 apple. So we can say that therefore omega plus omega minus, sorry, omega minus z is equals to minus 3 plus 6i. And that's your answer. Summarizing, we can only add and subtract our real values. We can only add and subtract our imaginary value. Let's look at the last question. Let's look at the last question. Part E. Part E. What is our value of 8 sees 50? 8 sees 50. Another full stop. Okay, let's take that out, another full skip. So this is 8. I'll just write the question down. So 8 sees 50 divided by 2 sees 25 in polar form. Okay, so that means we need to leave our answer in polar form. Okay, let's solve them. This is question 4. The question is saying 8 sees 50. What is sees? Sees is a value that is given in polar form. So this is r is our value r, and this is our theta. So this is 50 theta and 25 degrees. R is that. So the formula in dividing two complex values, I can rewrite this as saying if omega is equals to 8 sees 50 degrees and z is equals to 2 sees 25 degrees, what is omega over z? So omega is 8 sees 50 degrees over z is z 2 sees 25 degrees. Okay, the formula in dividing polar is this. So whenever you divide any polar form, the formula is R1, this is R1, divided by R2 sees, when we divide R, but we minus the theta. That's the first law. If we multiply two polar, this is for division, divide, polar. If we multiply polar, similar concept, R1 times R2 C's, since we multiply, we'll add the theta. This is the concept that we need to use here. Since it's dividing, we'll use that concept. So let's go. So this is omega over z, that is 8 C's 50 divided by 2 C's 25 degrees. So that is equal to, I will divide my R, 8 divided by 2 C's, then I will subtract using this formula, 50 degrees minus 25 degrees. So let's further simplify. 8 divided by 2 is 4, so this is 4. C is 50 minus 25. 50 minus 25, yes, 25. And your question, the question is saying leave our answer as polar form. So this is our answer in polar form. So therefore, 8 C's 50 divided by 2 C's 25 degrees is equals to 4 C's 25 degrees. If the question, normally the question says in polar form, but if the question is saying leave your answer in rectangular form, then we need to convert this in rectangular form using this concept that I showed you earlier. So 4, so we need to using the same concept, but in our case our value is given as my calculator is now not working, but anyway, you're able to convert this as saying rectangular. So you can press this as rectangular, so shift rectangular, and then whatever value comes first, so 4 comma 25, so press 25, close the bracket, equals, that is your real value, and then recall tangent will give you your imaginary value. That is if they are telling you leave your answer in rectangular form, but for this case it's telling us leave our answer in polar form. So in polar form, this is our answer. I hope you have understood and got that concept right. We'll stop over there. If you have any questions, please, you can drop me an email or a message so that I can guide you in your assignment. There's an assignment that is also uploaded. You can do that every week. It's due every week. Once your assignment is due, then we will discuss it, and then you will be able to do your quiz as you go along, just to test your knowledge and understanding under the topic of complex numbers. We'll stop over there. Thank you.